Bitcoin. Lately, Bitcoin has been a hot topic. Its price goes up, down, and so on. But this video isn't about Bitcoin's price. It's about a side of Bitcoin that's incredibly important, but often overlooked. This isn't one of those Bitcoin explained simply videos. There are already tons of those out there. Instead, we're diving into the more technical side, specifically the mathematical formula that powers Bitcoin's brilliant system. Let's start with a basic math equation. A equals B times C. Say we set B to 6 and C to 10. Then A becomes 60. Easy. 60 equals 6 times 10. But now let's flip it. What if we only know the result, 60? How do we figure out what B is? We could try factoring 60 into different combinations. But if we're given a clue, say that C is 10, it becomes much easier to figure out that B is 6. Now, here's where Bitcoin is different. The mathematical formula at the heart of Bitcoin looks like this. P equals K times G. But unlike the earlier equation, where knowing the result lets us guess the original numbers, with this one, you can't. Even if you know both P and G, you still cannot figure out what K is. This is the core idea behind ECC, Elliptic Curve Cryptography, the cryptographic system Bitcoin uses. But first, if you're new to Bitcoin, here's a quick rundown. Bitcoin is a digital currency system that runs on a decentralized network of computers. It allows people to send and receive money directly, without needing a bank or middleman. It's secure, transparent, and synchronized. Even without a central server, the Bitcoin network stays consistent and tamper-proof across all devices. Bitcoin was created by a person or group using the pseudonym Satoshi Nakamoto. Their true identity remains unknown to this day. Satoshi disappeared from the public in 2011, yet even without Satoshi, the system runs smoothly because it's decentralized and no one person controls it. And deep within Bitcoin's core code lies the ECC method, specifically a version called SEP-256K1. This cryptography is used to generate Bitcoin addresses, create public and private keys, sign transactions digitally, secure the network, and more. And trust me, this thing is seriously advanced. Okay, back to the formula. This isn't just regular multiplication, it's scalar multiplication on a curve. Here's how it works mathematically. Or this is if we do it with visual instead. Imagine a curve shaped like this. Now, if you add point A and point B on this curve, you draw a straight line between them. That line will intersect the curve again at a third point. Reflect that third point, and that's the result of A plus B, which we'll call C. Want to add point D? Do the same. Draw a line, reflect the new point, and you get E. So C plus D equals E. With P equals K times G, we start at point G. 2G equals G plus G. Draw a line, intersect, reflect. This is 2G. 3G equals 2G plus G. So we draw a line to point G, intersect, reflect. This is 3G. 4G, just continue the process, and so on. In Bitcoin, the specific curve used is this. This defines the path we follow while adding and reflecting the points on the curve. Back to the formula. P is the public key, K is the private key, and G is the generator point. The public key is what eventually becomes your Bitcoin address. The private key is like your secret password. The G value in Bitcoin is a fixed coordinate point with a massive X and Y value, something like this. A really huge number. Meanwhile, your private key is a random huge number between 0 and about 2 to the power of 256. So others can see your public key or address, but they'll never be able to guess your private key, no matter how hard they try. And that is the genius behind Bitcoin. We'll go deeper in a moment, but first let's try this with some coding. Let's start with a random number, a very large number, 256 bits in size. This number will be our private key. Then we multiply it using scalar multiplication with the generator point G, and we get a new point on the curve. This is the public key. From here, we transform the public key through several steps, more specifically hashing. First with SHA-256, then with RIPE MD 160, then some final encoding steps. And the result is a valid Bitcoin address. You can even check it on sites like Mempool. And this is a valid address. Right now, this address is still empty. Next, I'll try buying some Bitcoin and sending it to this address. You can buy from another person or through an exchange. And now if we check, it has a balance. So, from a random number, using the formula P equals K times G, we've generated a real working Bitcoin address that can receive and send money. No bank needed, and no one else can access it. At this point, I can both receive and send Bitcoin. Most people use wallet apps to do this. They generate the address for you. But if you're curious, you can also do it manually like I just did. For sending Bitcoin, you can also use a wallet app, but if you want to go full Satoshi mode, you can use Bitcoin Core. This connects directly to the Bitcoin network. Remember when I said Bitcoin is decentralized? This is what I meant. Anyone can run their own Bitcoin node with Bitcoin Core. That helps keep the network stable and distributed. If I want to send Bitcoin, I just input another address. Boom. Sent. You can see the transaction on mempool. It shows the source and destination. Anyone can verify it. Once validated, the data is recorded on the blockchain, unchangeable. No one can mess with it. And yes, with Bitcoin Core, I can even tweak the transaction data. Let's say I want to include a message. I'll send a small amount to Satoshi Nakamoto's address with a message, "Hello." Now if you check, you'll see my message has reached Satoshi's address. Pretty cool, right? If you want to try it yourself, feel free to send Bitcoin to one of my addresses. Now here comes the most important part. How does P equals K times G protect Bitcoin? We already said, you can easily calculate P if you know K and G, but it's impossible to reverse it to find K from P and G, because it's not regular multiplication, it's scalar multiplication on an elliptic curve. Y squared equals x cubed plus 7 mod P, with P equals 2 to the power of 256 minus 2 to the power of 32 minus 977. This means K, your private key, and P, your public key, exist in an astronomically large number space. P is around 10 to the power of 77, so it is like a number followed by 77 other numbers. This means that if we tried to trace back the calculation from the public key all the way to the private key, we'd be facing an unimaginable number of computations. Even if you tried to brute force your way to the correct value of K, you'd have to go through an astronomical number of possibilities. The fastest known method for solving P equals K times G is Pollard's row algorithm, which needs about the square root n operations. So for 2 to the power of 256, you need about 2 to the power of 128 operations, or 3 times 10 to the power of 38 operations. Let's put that into real-world time. So even if you tried 1 guess per second, it would take 10 to the power of 31 years. Used 1 billion guesses per second, still 10 to the power of 22 years. Even with all computers on Earth guessing at insane speeds, it would still take 110 billion years, over 7 times the age of the universe. That's why this is such a powerful security feature in Bitcoin. Your address can be public. People can try all they want to guess your private key, but mathematically, it's just not possible. Not even with all the computing power in the world. Your odds of randomly guessing a correct private key? 1 in 10 to the power of 77. Try hacking Satoshi's wallet if you like. People have tried, and failed. I've tried too. Still no luck. Which brings up the big mystery in the Bitcoin community. Why hasn't Satoshi's Bitcoin ever moved? My take? It's not because Satoshi forgot the key or died. It's a challenge, a bounty. Here's a pile of $100 billion unguarded. Take it, if you can. A bank needs vaults and guards. Enter the wrong password 3 times, you're locked out. But with Bitcoin, you can guess as many passwords as you want. It still won't crack. What's guarding it? Nothing, only math. So if you ever wondered why bother learning math, well, here's a reason. Learn math, get good at cryptography, crack a Bitcoin private key, steal Satoshi's 100 billions. That's a pretty decent motivation, don't you think?